When we looked up at the night sky, we saw thousands of tiny points of light scattered across the darkness. Ancient civilizations imagined gods living among them, distant worlds beyond human reach. But for centuries, one question quietly lingered beneath all those myths and stories. How far away are the stars, really? And more importantly, is there one close enough that we might actually reach it someday? Today, we begin a journey to the nearest star beyond our sun. A faint red ember hidden in the southern sky. A star so close that, in cosmic terms, it's practically our next-door neighbor. A star called Proxima Centauri. It lies just 4.24 light-years from Earth. That may sound unimaginably far, and in many ways, it is. But compared to the vast scale of the universe, it's astonishingly close. Close enough that astronomers have begun to wonder? What if the first alien world humanity ever explores is orbiting that very star? Because in 2016, scientists made a discovery that changed the conversation about life beyond Earth forever. They found a planet. A rocky world roughly the size of our own, orbiting inside the star's habitable zone. A planet known as Proxima Centauri b. A world that might, just might, have the right conditions for liquid water. For an atmosphere. Maybe even for life. And if that possibility is real, then the closest alien ecosystem in the universe may be orbiting a star only 4 light-years away. But there's a problem. The star itself is anything but friendly. Proxima Centauri is small, unstable, and violently active. It unleashes enormous stellar flares capable of blasting nearby planets with intense radiation. Which raises an unsettling question. Could a planet survive in such an environment? Or is Proxima b just another lifeless rock, scorched by its own star? To answer that question, we first need to understand the strange system this planet calls home. A system that astronomers have studied for more than a century. A system known as Alpha Centauri. And hidden within that system lies the closest star humanity has ever known. Long before astronomers discovered Proxima Centauri, they were already fascinated by another pair of stars shining brightly in the southern sky. These stars form the famous system known as Alpha Centauri. From Earth, they appear almost like a single bright point of light. But through a telescope, something remarkable becomes clear. Alpha Centauri is actually a binary star system. 2 stars orbiting each other in a slow gravitational dance. The first star is Alpha Centauri A yellow star very similar to our own Sun. The second is Alpha Centauri B, slightly smaller and cooler. Together, they form one of the most famous stellar pairs in the night sky. For centuries, astronomers believed that these 2 stars were the closest stellar neighbors to our solar system. But in the early 20th century, careful observations revealed something unexpected. There was a third star in the system. A tiny, faint point of red light located slightly farther away. So dim that it had gone unnoticed for decades. This star was later named Proxima Centauri, from the Latin word proxima, meaning nearest. And the name was perfect. Because measurements soon revealed that this small red star was actually closer to Earth than the 2 bright stars of Alpha Centauri. It wasn't just part of the system. It was our true nearest stellar neighbor. But Proxima Centauri looked nothing like the Sun. Instead of a bright yellow star, it was a red dwarf, the smallest and most common type of star in the universe. Red dwarfs are strange objects. They are cooler, much dimmer, and far smaller than stars like the Sun. In fact, Proxima Centauri has only about 12% of the Sun's mass. Its diameter is barely 1/7 the size of the Sun. And its brightness is so low that if it replaced our Sun, the daytime sky on Earth would appear more like a deep twilight. Yet despite their small size, red dwarfs are incredibly important in the cosmos. They make up nearly 75% of all stars in the Milky Way galaxy. Which means that most planets in the universe probably orbit stars very similar to Proxima Centauri. For a long time, however, astronomers had no idea whether red dwarfs could host Earth-like planets. Detecting planets around distant stars is extraordinarily difficult, especially when those stars are faint and unstable. But in the early 21st century, new instruments and new techniques began transforming the search for alien worlds. Astronomers started using extremely sensitive spectrographs to measure the tiny gravitational pull that planets exert on their stars. This method, known as the radial velocity technique, allows scientists to detect planets that are far too small and distant to see directly. When a planet orbits a star, its gravity causes the star to wobble slightly. That wobble shifts the star's light by tiny amounts. And with the right instruments, astronomers can detect it. Over time, these measurements began revealing thousands of planets orbiting distant stars. Entire solar systems scattered across the galaxy. But among all those discoveries, one system captured the imagination of scientists more than any other. Because if a planet existed around Proxima Centauri, it wouldn't just be another exoplanet. It would be the closest alien world in the universe. Just for light years away. Close enough that future spacecraft might actually reach it. For years, astronomers searched carefully for signs of such a planet. Watching Proxima Centauri night after night. Collecting data. Measuring tiny shifts in its light. And finally, in 2016, they found it. A small rocky planet, orbiting close to the dim red star. A world that would soon become one of the most studied planets beyond our solar system. A planet now known as Proxima Centauri b. But discovering the planet was only the beginning. Because the deeper scientists looked, the more mysterious this nearby world became. By the early 2010s, the search for planets beyond our solar system had entered a golden age. Powerful observatories around the world were discovering new exoplanets at an astonishing pace. Gas giants larger than Jupiter. Frozen worlds orbiting far from their stars. Even rocky planets not much larger than Earth. But astronomers knew something important. Most of those planets were far away. Hundreds of light years. Sometimes thousands. Even if one of them turned out to be habitable, reaching it would remain firmly in the realm of science fiction. So the search slowly shifted toward something more practical. The nearest stars. And at the very top of that list was a faint red dwarf just over 4 light-years away. The star known as Proxima Centauri. If an Earth-like planet existed anywhere near us, this was one of the most likely places to find it. But detecting such a planet wouldn't be easy. Red dwarf stars like Proxima Centauri are notoriously active. Their surfaces erupt with powerful magnetic storms and violent stellar flares. These eruptions can distort the star's light, creating signals that sometimes mimic the presence of planets. For astronomers trying to detect tiny gravitational wobbles in a star's motion, this was a nightmare. A planet might be there, or the signal might simply be stellar noise. Separating the two required patience and an extraordinary amount of data. In 2016, an international team of astronomers launched an ambitious project known as the Pale Red Dot campaign. The goal was simple in theory. Watch Proxima Centauri continuously for months. Measure its motion with extreme precision. And determine once and for all whether a planet was orbiting our nearest stellar neighbor. The observations were carried out using one of the most precise planet-hunting instruments ever built, the HARPS spectrograph. Installed on a telescope at the La Silla Observatory, HARPS was designed specifically to detect the tiny movements of stars caused by orbiting planets. Its measurements were unbelievably sensitive. Sensitive enough to detect stellar motions as slow as a few kilometers per hour. For comparison, that's roughly the speed of a person walking. Detecting a signal that's small from a star trillions of kilometers away is one of the most delicate measurements in all of astronomy. Night after night, astronomers recorded the light from Proxima Centauri. They measured tiny shifts in its spectrum, subtle changes in wavelength caused by the Doppler effect. When the star moved slightly toward Earth, its light shifted toward blue. When it moved slightly away, the light shifted toward red. Back and forth. Back and forth. A subtle rhythm hidden inside the starlight. At first, the signal looked almost like noise. Small fluctuations, nothing definitive. But as the data accumulated, a pattern slowly began to emerge. Every 11.2 days, Proxima Centauri appeared to wobble slightly toward Earth, then away again and again. The only plausible explanation was gravitational. Something was pulling on the star. Something small, but massive enough to move it. A planet. After months of analysis, the team confirmed the discovery. In August of 2016, the world learned that our nearest stellar neighbor hosts a planet. A rocky world with a mass very similar to Earth. A planet now known as Proxima Centauri b. The discovery instantly became one of the most important milestones in modern astronomy. Because Proxima b wasn't just another exoplanet. It was the closest potentially habitable planet ever discovered. And its orbit placed it in a very intriguing location. The star Proxima Centauri is far dimmer than our Sun, only about 0.2% as bright. That means any planet hoping to maintain liquid water would need to orbit extremely close to the star. And Proxima b does exactly that. Its orbit is astonishingly tight. The planet Proxima Centauri b orbits its star once every 11.2 days. To put that into perspective, Mercury, the innermost planet in our solar system, takes 88 days to orbit the Sun. Proxima b completes a similarly short orbit, meaning its year passes in less than 2 weeks. Despite this close orbit, the planet Proxima b still receives roughly 2/3 of the energy Earth receives from the Sun. That places it inside what astronomers call the habitable zone, the region around a star where temperatures might allow liquid water to exist on a planet's surface. And where there is liquid water, life becomes a possibility. But the story doesn't end there. The orbit of Proxima b introduces another fascinating consequence. Because the planet is so close to its star, it is almost certainly tidally locked. Just like our Moon always shows the same face to Earth, Proxima b may always show the same face to its star. One side permanently bathed in red starlight. The other locked in endless night. Imagine standing on the surface of such a world. Above you, the star Proxima Centauri would appear larger than the Sun does in our sky. But its light would look very different. Instead of bright yellow sunlight, the landscape would glow under a deep reddish hue. If the planet has an atmosphere, powerful winds might constantly circulate heat between the day side and the night side, creating enormous global weather systems. But the biggest question remained unanswered. Could this planet actually support life? Because while Proxima b may sit inside the habitable zone, its star is anything but gentle. Red dwarf stars are famous for their violent behavior. And Proxima Centauri is among the most active known. It frequently unleashes stellar flares thousands of times more energetic than those produced by the Sun. These eruptions blast nearby planets with intense radiation, powerful enough to strip away atmospheres over time. Which means that while Proxima b might occupy the right orbital distance for liquid water, its environment could be incredibly hostile. A world scorched by radiation. Or perhaps something stranger. Because if the planet somehow retained its atmosphere, then beneath the raging storms of its star, there could still be oceans, clouds, weather, maybe even life. And that possibility, however remote, has turned this small, distant world into one of the most fascinating planets astronomers have ever discovered. A planet orbiting the closest star to our Sun. Just 4.24 light-years away. Close enough that future generations might not just study it from afar, but actually visit it. Yet before humanity can even dream of such a journey, we must confront a difficult truth. Because the star Proxima Centauri is not a peaceful place. It is a volatile, unstable red dwarf capable of unleashing enormous cosmic storms. And those storms may determine whether Proxima b is a living world, or a barren one. From a distance of 4 light-years, Proxima Centauri may seem like a quiet and harmless red star. But in reality, it is one of the most unstable stellar environments astronomers have ever studied. Proxima Centauri belongs to a class of stars known as red dwarfs, small, cool stars that burn their fuel extremely slowly. These stars can live for trillions of years, far longer than stars like our Sun. At first glance, That sounds promising for the possibility of life. Long-lived stars give planets plenty of time for biology to evolve. But red dwarfs come with a dangerous side. They are magnetically violent. Inside these stars, turbulent convection constantly twists and tangles powerful magnetic fields. Over time, those magnetic fields snap and reconnect in sudden bursts of energy. The result is something astronomers call a stellar flare. And when Proxima Centauri flares, it does so with astonishing intensity. In 2019, astronomers observed one of the most powerful flares ever recorded from the star. For just a few seconds, Proxima Centauri brightened dramatically, releasing an enormous burst of radiation across space. In fact, the flare increased the star's brightness by more than 14,000 times in certain wavelengths. For any planet orbiting nearby, the effect would be devastating. And nearby is exactly where Proxima Centauri b resides. Remember, this world orbits its star in just 11 days. That places it roughly 20 times closer to its star than Earth is to the Sun. At such distances, Proxima b is constantly exposed to the star's volatile behavior. Each stellar flare sends powerful blasts of X-rays and ultraviolet radiation sweeping across the planet. Over millions of years, this radiation could strip away an atmosphere entirely. Without an atmosphere, liquid water cannot survive. Surface oceans would slowly evaporate into space. And any potential life would face a brutal environment. But the radiation is only part of the danger. Red dwarf stars also produce powerful streams of charged particles known as stellar winds. When these particles slam into a planet's atmosphere, they can gradually erode it away, much like how solar wind slowly stripped the atmosphere from Mars billions of years ago. The difference is that Proxima b experiences this process at far greater intensity. Some models suggest that within the first 100 million years of the planet's existence, most of its atmosphere could have been lost. If that happened, the surface today might resemble a barren desert. Cold, dry, and exposed to radiation. But astronomy is rarely that simple. Because new studies suggest something intriguing. Under certain conditions, a planet like Proxima b might still hold onto its atmosphere, despite the fury of its star. One possibility involves planetary magnetic fields. Here on Earth, our planet's magnetic field acts like an invisible shield. It deflects charged particles from the Sun, protecting our atmosphere from erosion. If Proxima b possesses a strong magnetic field of its own, it could provide similar protection. Another possibility is atmospheric thickness. If the planet formed with a very dense atmosphere, perhaps many times thicker than Earth's, then even billions of years of stellar bombardment might not remove it completely. Instead of stripping the atmosphere away, the radiation might transform it, producing exotic chemical reactions in the upper atmosphere. Perhaps even creating dramatic glowing auroras that blanket the sky. Imagine standing on the surface of Proxima b during one of these stellar outbursts. The star above you suddenly brightens. Within minutes, radiation storms sweep through the atmosphere. Charged particles crash into the planet's magnetic field. And across the sky, vast curtains of glowing light ignite. Auroras far larger than anything seen on Earth. Entire hemispheres shimmering in red and green waves. Beautiful. And terrifying. But the real mystery lies beneath the clouds. Because if Proxima b somehow retained its atmosphere, then liquid water might still exist. Not necessarily across the entire surface, but perhaps in a narrow region between the eternal day side and the frozen night side. Astronomers call this region the terminator zone. A thin band of twilight where temperatures might be stable enough for oceans, rivers, or lakes. In that twilight world, the star would hover permanently near the horizon. Never rising. Never setting. A dim red sun casting long shadows across a strange alien landscape. If life ever emerged there, it would evolve under conditions completely unlike anything on Earth. Plants, if they exist, might use infrared light instead of visible sunlight. Organisms could thrive in constant dusk. And ecosystems might develop in ways we can barely imagine. But all of this remains speculation. Because despite its proximity, Proxima b is still far beyond the reach of our current telescopes. We cannot yet see its surface. We cannot yet measure its atmosphere directly. For now, all we have are clues hidden in the light of its star. Yet the importance of this nearby world cannot be overstated. Because Proxima b is more than just another exoplanet. It represents something humanity has dreamed about for generations. The possibility that a living world might exist just beyond our solar system. Not hundreds of light years away. Not across the galaxy. But right here in our cosmic neighborhood. Only 4.24 light years from Earth. Close enough that, someday, human technology might actually reach it. And that possibility has inspired one of the most ambitious interstellar ideas ever proposed. A project that aims to send tiny spacecraft to the Alpha Centauri system within our lifetime. A project that could deliver the first close-up images of an alien planet orbiting another star. A project known as Breakthrough Starshot. For most of human history, the stars have been completely out of reach. Even the nearest one. The distance to Proxima Centauri is about 4.24 light-years. That number might sound small on a cosmic scale. But in reality, it represents an almost unimaginable distance. Light itself, the fastest thing in the universe, takes more than 4 years to travel between Earth and Proxima Centauri. Our fastest spacecraft, by comparison, are painfully slow. The Voyager 1, the most distant human-made object ever launched, has been traveling through space since 1977. After nearly half a century of flight, it has only traveled about 24 billion kilometers. That might sound impressive. But at that speed, reaching Proxima Centauri would take roughly 70,000 years. In other words, if we relied on traditional spacecraft technology, no human civilization alive today would ever see the results. And yet, in 2016, a bold new idea began to change that perspective. A scientific initiative known as Breakthrough Starshot. The concept behind Starshot is radical. Instead of launching one massive spacecraft, the project proposes launching thousands of tiny probes, each no larger than a postage stamp. These miniature spacecraft are called starships. Each one would carry a tiny camera, navigation system, communication equipment, and scientific instruments. But the real innovation lies in how they would travel. Instead of using traditional rockets, the probes would be propelled by light itself. Attached to each probe would be an ultra-thin reflective sail, a structure known as a light sail. Back on Earth, a powerful array of ground-based lasers would fire an enormous beam of light toward the sail. When photons strike the surface of the sail, they transfer momentum. It's an incredibly small force. But when billions of photons hit the sail every second, the effect becomes powerful enough to accelerate the spacecraft. In theory, the laser array could push the tiny probe to speeds approaching 20% of the speed of light. That's about 60,000 kilometers per second. At that velocity, the journey to the Alpha Centauri system could take only 20 years. For the first time in history, reaching another star system would move from science fiction into the realm of engineering. If successful, the Starshot probes would race through interstellar space for 2 decades. Then, as they approached the Alpha Centauri system, they would perform a rapid flyby, passing within millions of kilometers of Proxima Centauri b. During those brief moments, the probes would capture the first close-up images of an alien world orbiting another star. Not blurry telescope observations, but actual planetary photography. We could see its clouds, its oceans, if they exist, its continents, perhaps even the glow of an atmosphere around its horizon. The data would then be transmitted back to Earth using tiny laser communications. The signal would travel across space for more than 4 years before finally arriving. If everything worked perfectly, humanity could receive the first images of Proxima b sometime in the mid-21st century. And when those images arrive, they could answer one of the most profound questions ever asked. Is the nearest potentially habitable planet a barren wasteland? Or a living world? But reaching Proxima b will not be easy. Even at 20% the speed of light, interstellar travel presents enormous challenges. First, there is the problem of acceleration. To reach such extreme speeds, the laser system must deliver tens of gigawatts of power, more energy than some power plants generate. Second, there is navigation. At relativistic speeds, even a tiny collision with a grain of interstellar dust could destroy the spacecraft instantly. And third, there is communication. A probe no larger than a computer chip must somehow send signals across trillions of kilometers back to Earth. Engineers are still working to solve these problems. Yet the idea itself has already changed how scientists think about the future. Because for the first time, visiting another star system is no longer impossible. It is simply extremely difficult. And if Starshot, or something like it, succeeds, the Alpha Centauri system may become humanity's first destination beyond the solar system. But Proxima Centauri might not be the only world waiting there. In fact, astronomers have already discovered hints that Proxima b may have planetary neighbors. Other worlds orbiting the same red star. Some possibly larger. Some possibly colder. And perhaps one of them might hold something even more extraordinary. A stable atmosphere. An ocean. Or maybe signs of life. Because the search for life beyond Earth has now entered a new era. An era powered by telescopes capable of analyzing the atmospheres of distant planets. Telescopes that can detect the faint fingerprints of molecules drifting in alien skies. And at the center of this new era stands one of the most powerful scientific instruments ever built. The James Webb Space Telescope. A telescope that may soon reveal what the atmosphere of Proxima b is truly like. If it has one at all. Somewhere in the darkness of space, orbiting a small red star just for light years away. A world circles silently. A planet only slightly larger than Earth. A planet we call Proxima Centauri b. For now, we cannot see its surface directly. Even with our most powerful telescopes, the planet itself is lost in the glare of its star, Proxima Centauri. But scientists have learned an extraordinary skill over the past 2 decades. They've learned how to reconstruct alien worlds using physics. By combining measurements of a planet's mass, orbit, and stellar environment, astronomers can simulate what conditions might exist on its surface. And those simulations reveal something fascinating. Proxima b is almost certainly a rocky planet. Its mass is estimated to be around 1.2 times the mass of Earth, which strongly suggests a composition similar to our own world: iron, rock, and silicate minerals. But beyond that basic similarity, everything else about Proxima b could be dramatically different. The first major difference is gravity. With slightly more mass than Earth, Proxima b may have a somewhat stronger gravitational pull. Standing on its surface might feel subtly different. Not crushing, but heavier. Every step requiring just a bit more effort. The second difference is the length of its year. Because Proxima b orbits so close to its star, a full orbit takes only 11.2 Earth days. Imagine celebrating a birthday every week and a half. Time itself would feel completely different on such a world. But the most dramatic difference lies in the planet's rotation. Because of the intense gravitational pull from its nearby star, Proxima b is likely tidally locked. That means one side of the planet always faces the star, while the other side remains in permanent darkness. If this is true, the planet would be divided into 3 distinct regions. First, the day side. A hemisphere that permanently faces the star. Here, the red glow of Proxima Centauri would dominate the sky. The star itself would appear larger than our sun does from Earth, but its light would look very different. Instead of bright yellow sunlight, the landscape would be illuminated by a deep reddish hue. If the planet has oceans, the water might reflect a dim crimson sky. Mountains and plains would sit beneath a constant twilight-like glow. And if clouds exist, they might scatter the red light in strange and unfamiliar ways. But on the opposite side of the planet lies something even more extreme. The night side. A hemisphere that never sees the star. Forever locked in darkness. Temperatures there could plunge to hundreds of degrees below freezing. If oceans exist, they might be permanently frozen into vast sheets of ice. A silent frozen world beneath a sky filled with unfamiliar stars. But the most intriguing region lies between these two extremes. A narrow band circling the planet. A place where day meets night. Astronomers call this the terminator zone. In this twilight region, the star would hover permanently along the horizon. Never rising. Never setting. Just a dim red sun frozen in place. And according to climate simulations, this may be the most stable environment on the entire planet. If Proxima b has an atmosphere, winds could transport heat from the day side to the night side, balancing temperatures across the planet. Under the right conditions, this twilight zone could maintain temperatures similar to those on Earth. Warm enough for liquid water. Stable enough for weather systems. Perhaps even comfortable enough for life. Computer models suggest something remarkable. Instead of a single habitable area, Proxima b might support a ring-shaped ocean circling the planet. A permanent band of liquid water stretching thousands of kilometers around the globe. An ocean that never experiences sunrise. And never experiences sunset. Imagine standing on the shores of such a sea. Above you, the red star glows faintly at the horizon. Behind you, the sky fades into eternal night. Ahead of you, the ocean stretches into the glowing twilight. The waves moving under a sky unlike anything on Earth. But whether such an ocean exists depends on one crucial factor. The planet's atmosphere. If Proxima b lost its atmosphere early in its history, stripped away by stellar radiation, the planet today could be barren. A rocky wasteland. Dry. Cold. Exposed to cosmic radiation. But if it retained even a modest atmosphere, the story could be very different. And this is where modern astronomy is entering a new era. Because for the first time, scientists are beginning to study the atmospheres of distant exoplanets. One of the key instruments leading this effort is the James Webb Space Telescope. Operating far beyond Earth's atmosphere, this remarkable observatory can analyze the faint fingerprints of molecules drifting in alien skies. By studying how starlight filters through an atmosphere, Webb can detect gases like oxygen, carbon dioxide, methane, water vapor. On Earth, these molecules are closely tied to life. If similar chemical signatures were detected around a nearby planet like Proxima b, it would be one of the most important discoveries in human history. But detecting such signals is incredibly difficult. Proxima b does not pass directly in front of its star from our perspective, which makes atmospheric observations much harder. For now, astronomers rely on indirect clues. Future telescopes, including next-generation observatories currently under development, may finally be able to study the planet in greater detail. Until then, Proxima b remains a mystery. A world that could be a frozen desert, or a strange twilight ocean planet, or something entirely unexpected. But the deeper scientists look into the Alpha Centauri system, the more intriguing it becomes. Because Proxima b might not be alone. There are growing hints that another planet may orbit the same star. A larger world. Colder. Farther away. If confirmed, it would suggest that Proxima Centauri hosts an entire planetary system. A family of alien worlds orbiting the nearest star to the Sun. And that realization leads to an even bigger question. If planets are common around nearby stars, then how many potentially habitable worlds exist across our galaxy? Thousands? Millions? Perhaps even billions? Because the story of Proxima b is not just about a single planet. It is about a realization that has transformed modern astronomy. Planets like Earth may not be rare at all. They may be everywhere, waiting to be discovered.